Okay, so this video is just going to be of us practicing this skill of simplifying negative square roots or imaginary numbers. So if we had this function, this quadratic function, how are we going to find the solutions to this function? Well, we already know that the solutions are just another way of saying the x-intercepts. So if I have the x-intercepts, I know that my y is going to be 0. So I simply plug in 0 for my y. So if you look at this side of the paper, if I kind of, just cover this guy up for a moment, okay? And if we look at this, I can solve this by using the quadratic formula. I can simply go through and put my quadratic formula in. So I have x equals negative 14 plus or minus the square root of 14 squared minus 4 times negative 6 times negative 26 all over 2 times negative 6. And if I go through and do the math, I simply get this. So what it would be great for you to do right now is to actually go through, pause, do the math, and come back and check to see if you're right. So x is going to equal negative 14 plus or minus the square root of negative 428 all over negative 12. Okay? So how are we going to simplify the the square root of negative 428? So I'm just going to put a post-it note here for a minute, and I'm going to go through and I'm going to simplify this guy. Well, I know that the square root of negative 428 can also be written as the square root of 428 times the square root of negative 1. And I know that the square root of negative 1 is I, so ultimately my answer is going to have an I in it. How do I simplify the square root of 428? Well, I can kind of see that this definitely has a 4 in it, so I'm going to use the square root of 4, and if I do the division, I get 107. I know that this can't be simplified any further, so I know that this, the square root of 428, is 2 root 107. And we can't forget that this was a negative, so I have to put my I back into the problem. Into the solution. So 2I root 107 is the square root of negative 428. So I'm going to go through and I'm going to put that into my formula. X equals negative 14 plus or minus 2I root 107 all over negative 12. And I can keep going. I can simplify here. And we talked about this, but I'm going to be really careful. I can see that 14, 2, and 12 all have a 2 in common. I have to make sure that each of my terms, this term and this term, have whatever is in common with each other that we're going to simplify. So 14, 2, and 12 have a 2 in common. So I'm going to simplify the 14 to a 7. I'm going to simplify the 2 to a 1. And I'm going to simplify the 12 to a 6. Let's not forget that we both have those negatives in there. Okay? So my final answer for this, and I'm not ever going to find a decimal because I don't have a decimal, so I'm going to leave it in radical form, is negative 7 plus or minus I root 107 all over negative 6. And this is my final answer. Now what I did over here is I simplified up front. So again, I want you to pause. I'm going to go through and solve this using the formula, and I think you can kind of figure out what's going to happen when I get my answer. So pause, you do it, and see if you can come back when you're finished. So I'm going to go through and I'm going to put these guys in my formula. Negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. And when all is said and done, well, look at what I get. I get negative 7 plus or minus the square root of negative 107. Do you see that somewhere over here? All over negative 6. And now I know that I can't simplify 107. If I took my post-it note and I tried to simplify 107, I can't, because there's no perfect square factor. So I'm simply going to simplify it just by thinking about my I. So the square root of negative 107 is the same thing as the square root of 107 times the square root of negative 1, which means it's I root 107. So I can take that and put it into my answer. X equals negative 7 plus or minus I root 107 all over negative 6. And look at that. So of course we have the exact same answer. The reason why we had to simplify here is because we didn't simplify up here. But when all is said and done, you're still going to get the same answer. Okay? And that is how you simplify using imaginary numbers. I'm going to do one more. Again, I want you to pause, and I want you to try to do it on your own. So the function is y equals 17x squared plus 5x plus 2. What this looks like on the graph, we're not really concerned. We just want to see if it has x-intercepts, and we know that it doesn't. We know that it doesn't because I manipulated it that way. So I set everything equal to 0 because those are the x-intercepts. I go in, I put my a, my b, and my c into my formula, and I come up with x equals negative 5 plus or minus the square root of 25 minus 4 times a, 17, times 2 equals negative 111 all over 34. So, can I simplify 111? Does it have any square numbers? Does it have 9 divided by 9? No, it doesn't have 9, it doesn't have 4. This guy can't be simplified, but like I said, he can be kind of simplified by taking the negative out of the square root. So we're going to rewrite this guy as x equals negative 5 plus or minus I root 111 all over 34. And there's nothing in common, so we can't simplify this further, and we're done. Okay, so I'm going to give you a few more of these to do, just so you can practice. The last thing I want to end with is the name of these solutions. With quadratics, we've called these solutions. We've called them x-intercepts, and there's actually another name for them. They're actually called the roots of the equation. They're actually called the roots of the equation. So, I am going to give you a pop quiz on Monday or Tuesday, depending on which class you are. And if you watch this video like I asked you to all the way to the end, you will know that there are 3 names to the answers of a quadratic equation. One of the names is called the solutions. The second one is called the x-intercepts. And the third one, which is really new to you, is called the roots of the equation. The word is roots. The reason why they're called the roots is because the quadratic formula has a root in it, a square root, and that's why they're called the roots of the equation. Okay?